In this example, we consider a system that is not in equilibrium where multiple forces are acting. So Bob and Chris each push on a 10 kilogram crate in order to move it across the floor. Bob pushes with a force of 30 newtons and Chris pushes with a force of 20 newtons. In the first case, Bob and Chris push together to the right as shown in the figure, so we've got both of these forces are in the same direction, and we want to determine what is the acceleration of the crate, what is the weight of the crate, what is the support force acting on the crate, and hint, the crate does not move in the vertical direction, so there's no vertical motion at all, and therefore the sum of the forces along the vertical direction have to be equal to 0. So the very first thing we can do is we can determine the net force that's acting on this crate along the horizontal direction. And so that just means look at the horizontal forces, add them up, and since they're both acting to the right, the 30 Newton force and the 20 Newton force are both positive, so I get a total net force of 50 newtons. I know that according to Newton's second law, the acceleration is the net force that's acting on the object divided by the mass. So the net force is 50 newtons divided by a mass of 10 kilograms, which gives us an acceleration of 5 meters per second squared. So this means that the change in speed of this crate is 5 meters per second every second that goes by. That's what the acceleration actually is defined as. So we're also asked to determine what the weight of the crate is, and so we know that we can calculate the weight anytime we know the mass, because the weight is just mass multiplied by gravity. So that's going to be 10 kilograms multiplied by 10 meters per second squared, which gives us 100 newtons. And in our figure, we can go ahead and we can draw that weight as a vertical force acting downward because of the force of gravity. Now, there has to also be a support force acting in the opposite direction and perpendicular to the area of contact between the two surfaces, which would be this ground and the crate, so this perpendicular to this area here. And we know that the crate is not moving in the vertical direction, so the sum of the forces along the vertical direction, so going up and down, has to equal 0. So acting in the positive direction, upward, we have this support force, which we call the normal force, which is acting up. And then we have to add to it the weight, but the weight is acting down, so it's considered to be negative because it's acting in the opposite direction, which basically tells us that in order for these two forces to be equal to 0, that support force is going to have to equal 100 newtons. So the fact that it's not moving at all in the vertical means that all of these forces along the vertical are going to have to cancel each other out, acting in opposite directions or be equal to each other. So here we have the same type of question. I'm not going to read the question, but essentially one of the forces is now directed to the left and the other force is directed to the right. So it's kind of like a tug of war now. It's to see who can actually move the crate. So if we wanted to calculate the acceleration in this case, we have to go through and determine the net force again. And so that just means sum up the forces again along the horizontal direction only. And so I have a positive 30 Newton force that's acting to the right, and I have to add to it any other force along the horizontal, and I have a 20 Newton force which is actually acting to the left, which is the negative direction, which is why we have that negative sign there. So when we add these two forces together, the net force in this case is 10 newtons. So these two forces acting together are equivalent to a force of 10 newtons acting to the right. We can now determine the acceleration, which is just the net force divided by the mass. So we know the mass is 10 kilograms, so 10 newtons divided by 10 kilograms is an acceleration of 1 meter per second squared. So in this case, the change in velocity of that crate is only 1 meter per second every second that goes by. We could go through and calculate the weight again. This is the same crate, it has the same mass, so the weight is not going to change. And in the same regard, because this crate is not moving in the vertical, the support force is going to have to be the same as it was before, because the sum of the forces along the vertical still have to be equal to 0. And so that upward force, that support force, is going to have to equal the weight that's acting down.